Arg, me mateys! Captain Jack Sparrow is sailing into the harbor at night to avoid detection. His navigator observes a signal buoy at an angle of 15 degrees with the bow of the ship. So, Captain Jack Sparrow in his boat, he's traveling in a straight line. Now, somewhere out to the side there is a buoy. I don't know what a buoy looks like. There we go, there's a buoy. And the navigational person observes the buoy at 15-degree angle with the bow of the ship. He travels another 1,300 meters, and the navigator finds now the buoy makes an angle of 29 degrees with the bow of the ship. Now we want to know how far the ship is from the buoy. So the first time he spots the buoy, he's way over here, and he gets at an angle of 15 degrees. The second time he spots the buoy, he's out over here, and it makes an angle of 29 degrees with the bow of the ship. So what we're looking for is this length right here. Okay? Now we also are given that he traveled 1,300 meters between the two. So what we have to do now is find out our length here. So we name the triangle A, B, C. Now these are no longer right triangles necessarily. So what we're trying to find is A. Find A. Now, before I can find A, though, I can find angle C. Angle C is just going to be 180 minus 29 degrees. So it's going to be 151 degrees. So there's my 151 degrees, which also gives me now this, I have this angle, side angle. Now, angle, side angle is not one of my known triangles. So for our law of sine or cosine. So I find angle B as well. Angle B is going to be 180 minus the other two. 15 minus 151 degrees. So angle B becomes 14 degrees. There it is, 14 degrees. And now, if you notice, we are now given angle, angle, side. So now we have given angle, angle, side, which as we now know is law of sines. So we're going to use the law of sines to solve this problem right here. So I'm looking for little a right here. That's what we're looking for. It's opposite 15. So I go and take a look at what I'm trying to find. The sine of 15 degrees over little a. And I take a look. Do I know anything? Do I know a side with its opposite angle? Yeah. I know that the sine of 14 degrees, and I know its opposite side, 1,300. That's the law of sines. Cross multiply, we get a sine 14 degrees equals, use your calculator, you're going to multiply 1,300, there's my calculator. We're going to take this 1,300, multiply that by the sine of 15. Now, before I go any further, make sure I'm in the right mode. I'm in degree mode. Hit enter, and we get 336.465. So we get 336.465. And so to get A, we take that 336.465 and I divide that by the sine of 14. Just like this, I hit enter, and he's now 1,390.800 meters from the buoy. And there's our answer for Captain Jack. All right, let's take a look at number 2. That's a cool problem right there. Now, number 2 is always kind of a slightly harder problem. We have a signal flare that is seen by two observers, R2-D2 and C3PO. Now, they are 5.4 miles apart. So here's R2, and here is C3PO. They are separated by a distance of 5.4 miles. We won't deal with the curvature of the Earth in this problem. R2 observes the angle of elevation to a signal flare to be 20 degrees. So there's the flare, to be 20 degrees. C3PO measures it to be 32 degrees. what we're looking for is how high up is the flare. So we're looking for this distance right here, the height. Now, in order to do this, we're going to break down the triangle. Now, I need to find this angle right here, this whole angle. Now, to find this whole angle, that's easy. So if I call this A, let me use blue here, A, B, C. If I want to find angle B, that's going to be 180 minus 20 minus 32. And if we just type that in our calculator, 180 minus 20 minus 32, we get 128 degrees. So there's 128. Now you might be asking, why do we want this? Okay, well if I draw it out again, ignoring the height part, there's 20, 32, 128, 5.4. I can find this length, A, B, C. I can find little a. Now the reason I want little a is because if I drop the height, which is an altitude, little a, I can use right triangle trigonometry to get the height of it. So I need a. And what can I use to get a? I have angle, angle, side. So since I have angle, angle, side, I can use the law of sines to get little a. And that's what we're going to do. So a is opposite 20. So I go to sine of 20 over a equals my known, the sine of 128 over 54. So cross multiply, a sine 128 equals, I type that in my calculator, cross multiply here, 54 times the sine of 20, not 209, we get 18.469. And I'm just going to divide by the sine of 128. So I take the 18.469 divided by the sine of 128, and I get 23.437 miles. Wow. That's a lot. 23.437. And now we're ready to actually get the answer. What I'm going to do is only, and I'm going to do this one in red, is look at this right triangle right here. If I look at this right triangle, just that right triangle, we're looking for h. We know our angle down here is 32 degrees, and we know this is 23.437 miles. So, how can I find h? That's my opposite, given the hypotenuse. Use sine. The sine of 32 degrees equals the opposite over the 23.437. H therefore equals, if I type that in my calculator, just cross multiply, take the 23.437, times that by the sine of 32, and we get 12.420 miles. So the flare is about 12 miles in the air. Not necessarily a real world problem because that's kind of tall. But anyways, it works out. So what I would encourage you to do before you move on to part 2 is maybe work number 2 again. Because that's a tough question. It's one of those. If you can do this one, you can do anything we throw at you. All right. So come back and do part 2 in just a few moments. Okay? Thank you.